Alright, grade 10s. So welcome back. A little lesson on common factors here. First off, a bit of vocabulary. The GCF is the greatest common factor. As greatest common factor, we're talking about the largest factor that's shared by two or more terms. The largest factor that's shared by two or more terms. And so a little example, if we take something like 16 and 28, and the colon there isn't important, and we want to determine the GCF, one of the ways that we can do that is to look at the different factors of each number. So for example, the numbers that divide evenly into 16, so 1 and 2, 4, 8, 5 doesn't work, 6, 7 doesn't work, 8's the next one, and as soon as you get to halfway up to a number, that's the last factor, and the next one will be 16. So same with 28, we've got 1 and 2 and 4, 5 doesn't work, 6 doesn't work, 7 does, 8, 9, 10, 11, 12, 13 don't work, 14 does, and that's halfway, so the next one's 28. Now the biggest number that both of those have in common, the greatest common factor, will be 4. So the GCF is 4. The other piece of vocabulary that we're using is the lowest common multiple. So the lowest common multiple is the smallest multiple that's shared by two or more terms. So remember, factor is a piece that makes up the two numbers. Multiple is made up by the two numbers. So if we took numbers like 6 and 8, what I try to do when I determine the lowest common multiple is I'll take the biggest number, the 8, find a couple of its multiples, so 8, 16, 24, 32, and then look to see as I'm going through that list, as I'm building it up, I'm wondering, does that divide by 6? Does the next one divide by 6? So is 8 divisible by 6? Is 16 divisible by 6, etc., until I find one that's divisible by 8 and by 6. So in this case, the lowest common multiple is 24. So on page 215, we did a couple of questions out of the Investigate. The first one had to do with using prime factorization to find the greatest common factor. So with numbers like 60 and 48, prime factorization, like we learned in the previous chapter, we divide by the lowest possible prime number that goes into 60. So 2 times 30, and then 2 times 15, and then 3 times 5. So the prime factors are 2 and 2 and 3 and 5. For 48, we do much the same thing, except this time we get 2, 2, 2, 2, and 3. So to find the greatest common factor, we look for the numbers that are common. So we've got 2 2's and a 3 in each one. So my greatest common factor is 2 times 2 times 3, or 12. In question 3, something about the lowest common multiple, we've got numbers like 12 and 15. So as I mentioned before, what I do is I take the bigger number, the 15, and I start finding its multiples. So 15 times 1 is 15, times 2 is 30, then 45, then 60. All the while asking myself, does that divide by 12? Does 15 divide by 12? No. 30? No. 45? No. 60? Maybe. Another way is to find the multiples of both numbers and just keep building up the list until you find something that's common. Now, the other part here is if we're looking at powers. Something like 6 to the power of 2 and 6 to the power of 3. When you're asked to find the greatest common factor of a power, especially if the powers have the same base, we can think of that as, well, 6 squared is 36. 6 cubed is going to be 36 times 6, so the greatest common factor is 36. Another way is to look at the factors of, or how is 6 squared made up? It's 6 times 6. 6 cubed is 6 times 6 times 6. So each of those has two 6's in common. So the greatest common factor, 6 squared. For the 8's and for the x's, it'll continue to be the smallest exponent.